I'll skip that other 2.11 and I'll go to the last one and then we'll look at the 2.11 because I have to think about that one. Okay, so next one is you create a cost function. You want to see if a document has been plagiarized. You create a cost function of 1 for every deletion, insertion, space created between two documents. What algorithm would you run to provide you a score of how different two documents are? This is another example of that type of question. Again, all you need to provide as an answer is what algorithm you would use, and the algorithm you should use for this is edit distance, and it's 1-to-1 to edit distance, right? This is edit distance. I just wanted to show you an example of edit distance. Okay. And then this one. So this one is you have a graph and you want to, in n plus n time, figure out if there's a path from I to j and j to I. And then, so you can pre-process using that. And then you also, and you're going to be storing it in n space. And the goal is to find whether there's a path from I to j or j to I, and if it's yes to both, if there's a path, then the answer is yes, and if there isn't, the answer is no. So, well, let's think about this. How could I answer if there's a path between two nodes in n plus n time?
Connected, they belong to the same connected component.
So DFS or BFS will tell you in m plus n. So m plus n is the number of vertices and nodes. Both DFS and BFS run in n plus n time, and they both will tell you, both of them, both DFS and BFS in O in n plus e time, or e plus v time, tell you who is connected to who. Okay. So both DFS and BFS will tell you that. How can we answer this in O of in n space? Okay, so DFS and BFS tells you who's connected, and you have so you want. So DFS and BFS find all paths from some node to all other nodes, right? That can be reached. So both of them can do that. And what does it say to answer the question? It has to run in O(n) time too, or no?
That's pretty good.
And store the information if you can meet the time space. Given a graph, we want to process a graph such that we're given. Okay, so basically there's no run. It just, you need to, the word preprocess is useless. In this case, you just need an algorithm that in m plus n time gives you a set of nodes such that I can be reached, such that you can answer the question, can I go to J or j go to I, right?
And
And you wanna keep this all in n space. Go ahead.
Well, if during the pre-processing, you create instead of something like, maybe this could be totally wrong, but you create instead of adjacency list, like a connected queue list for each node. Wouldn't that, if you pre-process the graph, and you basically in O of n, you just traverse the amount of nodes you created in your pre-process, and then you can answer yes or no if that connection exists. Does that make sense?
Yeah, I think you're sort of saying like, here is some traversal, right? Of, some traversal of, a BFS traversal of, from a certain node, right? So if I point to here, this means that I can reach all those nodes. And if I point to here, this means I can reach all of the nodes below that. So if you just somehow, instead of pointing to an edge, you point to an edge that, you point to a node that points to things, then you could have a structure that answers this question. So let's think about that. This one, I don't think this one would be on the test because it's taking me longer than 1 second.
so this is kind of like so we are testing if it has both I to j and j to I.
Yes.
So that's essentially testing if two nodes belong to the same connected component in an undirected graph. And in an undirected graph, if you want to find if two nodes are connected, it's O B plus E, right? That's O n plus n via BFS or DFS.
Yes, but you want a data structure that answers that question, so it has the answer already stored, right? In O(n) time,
Okay.
you want to know the answer, basically, but
Which question is this?
2.1 of the design.
Question. Would BFS work if the graph is disconnected?
Well, it wouldn't work, it would only work, so the way BFS would do it, it would pop all the other ones as infinity, right? So from the starting node.
But this is for like any two arbitrary nodes, right? So
Yeah.
maybe we wouldn't be able to use BFS
If they're non-connected. Well, you could, once you finish, then everything else is infinity, you could rerun it starting at that node or something.
But would that give us a worse runtime then?
Then DFS,
Yeah, it could be E times E plus B.
if everything's disconnected.
Yeah.
Yeah, that's true. But how would, so let's say we're BFSing, or DFSing. I mean, the question's also hard because it says fast, but it doesn't say in O(n) time or O(n) time. I guess I think that it's legitimate to have it in O(n) time.
Yeah.
That's pretty good. No, you think faster?
No, O(n) is good. O(n) is good.
It's too slow? You
No,
think?
it's good. It's good.
Oh, okay, well then given that it's a tree and we somehow point to everything that things are connected to, let's for a second assume we had this data structure and it looked like this. Okay? Then how long would it take me to get every node that I'm connected to if I have a tree? What's BFS on a tree? It's just well, it's still B plus E, but how many edges do you have in a tree? Your edges are bound, right?
E minus
E is bound by B minus 1, right? Go ahead.
So, the question is O(n) space. So, yeah, you have a pointer for every node. And you, worst case, have a situation where you have to traverse every edge from the source to get from I to J. Then you would still be navigating in O(n) space.
Yes. Assuming that there's nothing like this going on, right? If it's not a tree, then you would have more than n space.
Yeah.
So you definitely need a tree somehow.
Yeah.
Which storing a tree takes V space, okay? storing this kind of tree will take V space, because there's V edges, V nodes. So this question is fun, and let's do it, but I think let's move on to other questions, because this is just, I picked random design questions. Before I give you one, I will test that I can do it in like 2 minutes. If I can't do it in 2 minutes, then you guys can't do it in 10. Or if I can't do it in 1, you guys can't do it in 10. So, I mean, we're all getting the right idea, which is that somehow creating a tree, then breadth first searching or depth first searching through the tree is fast. But it's a good true and false question. How long does it take to breadth first search a tree? Is it linear in the size of nodes? The answer is yes.
Yes.
Because DFS and BFS and BFS, what's their runtime? It's E plus V, right? Both of them have an E plus V runtime. If you have a tree, what's E? E is always V minus 1. So then your DFS and BFS of a graph that is a tree is always just going to be. And I think we even had something like this there was a question that asked you DFS in linear time or something, or it was a homework question, and you basically said if there's more edges, checking if there's a cycle. That was a good question. That was a good design question. Checking that you have a cycle in linear time. Do you guys remember that one? It was in the last homework. And the answer to that one was that if you have more edges than V minus 1, there's a cycle, period. You don't even have to do it. And if you don't have more than that, you should run DFS, and that will give you the answer if there's a cycle. So, okay, anyways, that was 2.1. We'll come back to 2.1. I'm sure that there's some answer to it. Let's start with the actual running algorithms, unless you guys have other questions. Somebody said, how can I tell what is what? How would I be able to answer the design question, right? So an example, finding a cycle. How can I tell? I just think, let's go through all the algorithms you guys learned, and then hopefully, there's some intuition. I can't teach, can somebody tell how they can tell? I don't know, it just becomes natural to you by seeing the same problem over and over again. It's like, how can you tell? I think it's the same question as if I have 2 apples and 3 apples, how many do I have all together? How do you know it's plus? You just know because you've done it enough times, maybe? I can't teach that part. I'll try to by giving enough examples where you start seeing the same problem over and over. Okay.